So with that, I'm very happy to introduce Kelsey Hightower. Thank you.
Please accept my apologies for being late. I was in another session, and people that care about me had nice things to say, and I wanted to listen to them. So please accept my apologies. Thank you.
Thanks, Kelsey. And I think one of the things that people love most about you is your engagement with the community and really bringing a personal touch to things. Something I've heard recently, which really resonated with me, was that technical skills are obviously very important. We're all here. This is a tech conference to build technology, but personal skills and the personal touch is really your first multiplier, right? When you interact with your colleagues, even in the development process, right? PRs, if you have a jerk on your team, it's very painful to go through that process with your engineering team. And so my focus as an engineering leader is very much on making sure that we hire great technical talent, but are also connecting on a personal level. So I appreciate that you bring that to the community as well.
I appreciate recognizing it.
So I think we have a few kind of discussion points we can talk about, but I think what would be very interesting is to open it up to the crowd as well at some point. So first I just want to get your high-level impressions, right? You saw the first KubeCon. I was just hoping to get some of your impressions. You've seen the first KubeCon, you've been at many of them, obviously. Like, what are the big trends you've seen? How have things changed? What's surprising? What did you expect that didn't happen? That kind of thing.
We definitely never thought it would get this big. When we created KubeCon, there's 3 people: Joseph Jacks, Patrick Riley, and I think most of this idea was formed at GopherCon. We wanted something like GopherCon for the Kubernetes community. Remember, when Kubernetes came out, no one thought it was going to work, right? Oh, Google, it'll be dead in a week. Swarm is better. Mesos is better. Not sure this is going to be a thing, but there was enough people excited about it. And so we decided that we would make a very organic conference that ran like a meetup. And as part of that, I agreed to be the moderator. And I wanted the community to behave in a certain way, meaning we're not at war with the other open source projects. So when people would use that language on social media, I was like, hey, we're not out here to kill Mesosphere. We're literally just trying to have a new take on these ideas. And so that thing that felt like a meetup turns into this. And that means I think we did a good job in that we influenced people with these ideas that there is a better way to do the same thing. A lot of these projects are mostly remixes of the things that came before, but with this new concept around cloud native or API driven, and we're not waiting for the vendors to decide what we do. It was the first time in my career that all the vendors decided, almost at the same time, that they were no longer going to be able to dictate where technology was going. The community was driving it. And so now I look up and you can see the influences of Prometheus and Kubernetes, and Linux is bubbling up all the way to the top. And so now it feels like there's a real partnership between the community and the companies who ship and build technology. They're becoming one and the same. So I never thought it would get this big, and I never thought it would be around this long. Oh. No, I'll figure out a better way to do it.
Just I want to hear. Just put it close to you.
Oh, okay.
I've been messing that up this whole time, yeah. That resonates with me as well. My kind of narrow view has been working on the storage and database side. And when CSI came out, for example, it was really a partnership between Swarm and Mesosphere and Kubernetes, the Kubernetes community, to build something that was usable by all these different orchestrators. I think Kubernetes, by and large, is one, in many ways, but it really focused on helping each of these systems build something that really made sense for the end user, which was really cool to see. That's good to hear from you as well. I think our session here is really our booth and our company here is really around storage, and I know there's been a lot of debate on is Kubernetes too complex? Is it possible to run databases and things on Kubernetes? I know that you have an interesting perspective here because you've seen the whole evolution of Kubernetes over time, especially regarding how there's different levels of support for stateful primitives. And I will say that I think there's more and more we can do. We're actively contributing to things like change block tracking, and I'm really excited for volume group snapshots, which just came out in 127. Can you maybe give your perspective of that side of the timeline as well?
Remember, I'm not an authority on any of this. I just have opinions, like y'all have opinions. And my opinions are rooted from being a system administrator, wearing a pager, waking up in the middle of the night, like, why the hell did we make this decision? Because it has consequences. When Kubernetes comes out, There's no volumes. And people are like, this must be a mistake. You need volumes. And it's like, not really. Where Kubernetes comes from, most people don't mix distributed systems and POSIX. I thought we would have learned from NFS. You guys remember NFS? Probably still use it. When that kernel locks up and your file system is hanging on file open, you're realizing that there's a network. And when you lie to an application that it believes that it's talking to a local device and that open's gonna return fast and that close is actually gonna work, and it doesn't because there's a network problem, and you restart the whole server because the NFS volume that's dealing with logs is broken. And if you were the pager, you say, why are we even doing this? Why are we mounting logs via NFS? We should send them over the network using syslog. Stop writing logs to files and rotating them. It's a nightmare, and people built all these Rube Goldberg machines to manage logs. Stop. Send it over the network. Put a bit of context in your logs. I'm from this host. This is the issue. Put semantic meaning and send it to a real database where you can index the logs, query the logs, graph the logs. Don't log into the server with SSH and that long-ass grep command that no one understands, but you gotta use it if you wanna figure out what's in the logs. We're doing that for 20 years. Stop. So if you zoom forward, we learned a lot of things about data. Databases are a thing. All apps have state. And most apps are stateless at the same time. The Oracle binary doesn't ship with data in it, does it? You don't recompile the Oracle binary when you do an insert. So Oracle itself as a binary is stateless. It writes its state explicitly to a volume or a file. That's what it does. It's stateless. But you put it next to the file system so you can store your volume and your data safely. That's what we do. Over time, we learned a better way. You can build tools that are distributed systems that deal with blocks in a slightly different way. And you can teach the database how to do that. So then you get BigQuery, you get Spanner, you get CockroachDB. And what you do is you remove all the disks from all the servers. There are no drives. There's only netboot. Your app comes up and it's read-only. And if you want to write data, you send it over the network to an explicit data protocol. If it's an object, you put it in an object store. If it's a database, you use the driver and you send it to the database. Where's the database? Doesn't matter. It's wherever I've given it to you with this locator. If you work in ops, you ain't backing up no servers because there's nothing there to back up. We were smart. We put the data where it belongs and you treated the database special. That's what you did. So that way you didn't have to treat any of the other apps special. And then we scale. Beautiful combination. This is where that 12-factor app pattern comes from. It's a good fit for distributed systems where consistency is hard. This is what we learned. So Kubernetes comes out and it embraces the fact. And then something happened. The enterprise showed up. And they asked a very simple question: can you make the new thing work the old way? We want the volume back. We do not want to write our app to be explicit about data. We just want to put data somewhere and we will back up the whole disk because we don't know where the data actually lives. Some of it's in varlib, some of it's in Etsy. Not sure why you're storing parts of your database in Etsy because you're using SQLite and that was the only writable partition. But so is life. And this lack of explicitness is at odds with distributed systems. If you don't know where the data is, you're going to get in trouble. And then your cluster slowly turns into a snowflake. And now you're backing up Kubernetes. And instead of solving authorization, security, observability, we're back re-implementing POSIX for the 100th time. Same protocols again. Now, there's a reality. You can't rewrite all the apps. So we need POSIX. So I'm pragmatic. I understand that this will happen, but you have to understand why it is fighting against, why it's been taking 10 years of us trying to add volumes back to Kubernetes. Because it's at odds with distributed systems. So my advice for a long time has been, listen, make sure you understand how to run a database on a VM or bare metal first. Most people don't know how to do that either. Most people just get the perfect server with a RAID controller, and they've never shut it down. They've never migrated it anywhere before. And then they say, oh, Kubernetes, you're going to now move it. No, you're not. You lack the skill. And so that's been my fundamental opinion. It's not that I didn't think it's possible, but it's totally possible. But the level of expertise to make it possible is beyond the means of the average system administrator. And a stateful set is so far from what needs to happen that you need all these other things, CSI, replication tools, the database to become aware of the situation like console and etcd and CockroachDB. That's what needs to happen long term. So I still hold this opinion. 10 years later, Kubernetes can only meet you 25% of the way. The database at some point has to realize the game is different. The volume may not be right there. Maybe you can have more data than can fit in any volume attached to a machine. And so that BigQuery model where you have tiered storage, in-memory, SSD, slow spinning disk, and the network storage all in one. That is what people are doing. There's a company here, Red Panda, that's what they do in their Kafka clone. They now have the ability to say, hey, memory, SSDs, and we will page everything else to S3 in real time. If you reboot this binary from scratch, it will load the important bits back onto the file system, and it will load the things that are hot into memory. A nice, transparent file system. The file system needs to expand beyond POSIX. That must happen, and we're not going to do that with CSI alone. I know it's a long-ass answer, but I think the context is important.
No, I definitely appreciate that answer. And right before you joined, I polled the crowd, and actually it seemed like Postgres was the most popular database people were running. So they're definitely still using these older style databases in Kubernetes. So
and the dope thing about Postgres is that the protocol is dope. So dope that CockroachDB implements it on top of their database that does all these things we're talking about. So I think we got to move beyond like just the one implementation. But you start to see like AlloDB from GCP also has an optional storage model that allows us to use our internal Colossus to get around this POSIX limitation. So I think for us as a community, yes, we need to do the hard work to be compatible with the existing world. I think that's why Docker is largely successful. They didn't tell you have to rewrite all your apps. You got to reuse the same apps, but packaged in a container. Be aware of those kind of CPU limitations in JVM, but for the most part, you didn't have to rewrite everything. That's a beautiful world. But we shouldn't stop pushing for the real change that needs to happen. In my opinion, POSIX and distributed systems don't mix. The protocol was not built for the network. It doesn't even allow you to express the concerns of a network file system. You need versions. We need consistency. That's hard to do with POSIX alone.
Definitely. And I think this point can be even generalized to Kubernetes in general, where Kubernetes is an abstraction layer, and if you look around, there's actually still a lot of work going on that abstraction, but there's also a lot of layers you need to build on top of that with your own teams, operations. You can use things like Cloud SQL to build out your operation team that way, or you can do it yourself. I mean, if you look around, like there's many vendors here that will fill in the gaps between those different layers, and that's not true just for storage, but I think across the board for all types of infrastructure, logging, big data, all these other things, right?
I mean, one pattern that I like to see that aligns with reality, that aligns with pragmatism, is I've seen a lot of good patterns where people will keep, like you got one flat network, right? Like a VPC in the cloud provider or on-prem, and you take all your stateless stuff and you put it in its like own stateless set of clusters. And you put that database or stateful stuff in its own cluster. And now you get a decoupled lifecycle. You can move pretty fast with your Kubernetes upgrades over here without worrying about data moving around and complexities that come with that. But then over here, you can treat this a little bit more special. The nodes are bigger. Maybe you're using different type of block devices. You're aligning with reality, and then you can go and use CSI and the various operators, but you can isolate that to just this data environment, and then you can have the same app on the same subnet, still talking to the same database, same latency profile, but you decouple the lifecycle. This shouldn't be foreign. We did this back in the day. Remember, there used to be Nginx or Apache, your PHP, and the database on the same server. You're like, wow, this is cool. Look how much money we're saving. And then you have that outage. It's like, I think we should move the database to a different server. And then we get the 3-tier architecture. Load balancer, web apps, database. So Kubernetes is probably open to the same pattern in terms of reliability and keeping all your clusters from becoming snowflakes.
I think we have a quick question.
Can't you achieve this? Sorry, Kelsey. can't you achieve the same thing with taints and tolerations? For example, we've done a lot of work to ensure that applications and databases live in the same clusters so that we can leverage services, Kubernetes services, so that applications don't even realize that there's been a failover. And we actually we've seen that dedicating, for example, even hardware, Kubernetes on hardware with local disk and dedicate them for Postgres is actually providing us with very high, RTO, RPO, and also performance, like TPS.
The answer is yes. Kubernetes typically runs on top of VMs or bare metal, same Linux stack that you had before, same networking you had before. This is not a new architecture. So Kubernetes, out of the box, will place things where you tell it. You have things like taints and tolerations and affinity policies to say, in this set of nodes, only run database stuff, right? So you are pretty aware that, hey, Kubernetes, I know I have 1,000 nodes in this cluster, but these 3 are just for the database. Also, never move these 3 to any of these nodes. Also, never do this. Also, make sure the volume gets attached here. Also, by the time you're done with the alsos, right? There's this project on GitHub called Vitesse. You ever heard of it? Vitesse is like a thing to help you run tools like MySQL on Kubernetes. Let's say Kubernetes is 1 million lines of code. Vitesse is like 1.2 million lines of code. And so you say the delta between what Kubernetes does out of the box and what you need to be aware of to run MySQL the right way is high. So remember, the people that are trying to do this, at least 7 years ago, they didn't really have a lot of experience on how to run MySQL on static infrastructure. They didn't even know how Kubernetes worked. But boy, when they saw that demo, kubectl apply MySQL, they were like, oh my God, we're going to production. And then the volume would go away. It's like, hey, where's the volume? You're like, I don't know, I didn't put it there. Kubernetes did. There is no command for where is the volume. It's just not there. The stateful set says it's there. The little volume thing says it's there, but you know it ain't there. There's something wrong. So that expertise, that's the gray area. So if you know what you're doing, you can brute force Kubernetes into carving out special node pool and using selectors and taints and anti-affinity, mounting volumes and making sure they never move around. Basically telling Kubernetes, stop doing most of the things you want to do because this thing cannot handle it. Or you can get a VM and name it. Lock the thing down. Let the cloud provider do live migration for you. Keep the same IP address and look at it and pray to the gods that nothing goes wrong, but if it does go wrong, you can log in and save the day. Or you can get on Twitter like, hey, I don't know where my MySQL volume is. Anyone knows where this controller object thing puts it because we're screwed right now. So I think a lot of people are still in this phase where this is probably the best thing. Now, I counter this for dev. Dev, I don't need high reliability for MySQL. I don't care if it gets blown away because it's easy to restore. Kubernetes is beautiful for giving every developer their own database and their own namespace. This is beautiful, and we should keep doing it. But that caveat is important, so I agree with you. You can do it in Kubernetes. But what's required, Kubernetes is missing a lot of stuff to make this automated. We'll get there, but I want people to be pragmatic along the way. There's a question back there as well.
Okay. So in February, I understand you finally gave your blessing to running databases on Kubernetes. Is it correct?
I didn't know I can give blessings. I'm adding that to the resume.
There you go.
No. What I did was acknowledge the same thing. Kubernetes runs on top of VMs. Of course you can do it. Do you know how we were doing it when I was at CoreOS before we had an actual volume type? Amount of volume to the server, like we've been doing for 20 years.
Correct.
And then have that container only run on the server that has the volume. Net equals 0, and just take the IP of the host. You're done. You can run a database on a Linux server, it turns out. So there's no reason why you couldn't do it with Kubernetes. At that time, I just knew what it took. So a lot of times now, I think people are just getting confused about what's actually required. So if you're new to Kubernetes and you see stateful set, and you realize that it's not really that stateful,
Yeah.
that's the thing that kind of throws people off. So I've been cautioning people for years to think about the nuance. So it's not really a blessing.
Right.
It's just me being honest and transparent. It's always been possible, but there's a caveat.
Got it.
Did you say there was one?
Any questions?
Any other questions? I think the high level for me is that Kubernetes is very powerful. There's maybe a perception that it's a little bit complex, but really what it is a set of primitives that let you go build your infrastructure on top of it. And it provides useful abstraction that lets you manage your failure domains if you understand the right primitives. It lets you manage, use different cloud providers, different geos in the same kind of way, using the same type of abstractions. But there is a big gap between a production-ready system and something that you can just throw into Kubernetes with a single command, right?
Yeah, I mean, there was this engineer that came up to me at one of the conferences and said, hey, Kelsey, Kubernetes is too complex. How could you even use something so complex? I was like, you know what's more complex? Your body. And I guarantee you don't know how your body works, right? It's very complex that you wake up every day and do very simple tasks. In many ways, it's overkill. Do you really need both legs? You may not need both. Is a thumb really that important? And we evolved over time to meet the complexities of the world. What did you think was going to happen in the next system we built after the cloud era? People are asking people to scale to thousands of machines, to encrypt data, to be explicit about bin packing because cloud is getting expensive. And we need to be able to find a better way to do resource sharing because that piece was missing. You can't use bash scripts to do all of this because we tried that already. And then we went to config management, and then the problem got more complex. People want to run multi-region. They want to have things be automated in terms of when an app comes up, it should be connected to the load balancer. So the idea of service discovery was born. All the things we read in the papers for decades around distributed systems became real. Remember, there was a point where it wasn't possible. It was too expensive to implement some of these distributed system protocols. They required way too much. But then we figured out how to do it. And then we put it all together and gave it a name. It's called Kubernetes. It leans into the complexity of what a distributed system has to deal with. And it gave us an API to reason about it. It's a hard thing. But now some people say kubectl apply. kubectl apply my deployment, service creates, ingress create, and now you have a horizontally scalable thing with automatic service discovery and explicit RBAC all the way down to the details of what volume to mount. Who was doing that before? You weren't doing that before. You were the scheduler. You had your little spreadsheet with all the nodes in it. You copied that to Ansible. You made some playbooks. You ran them across the machines. And you cry. And then we created a whole group therapy called DevOps, where we can come together and talk about all of our ills, the learning curve of managing all of this stuff. So when I think about the complexity of Kubernetes, it just embraces that this stuff is hard. Just like the human body has evolved to the task, Kubernetes has evolved to the task. And we can't confuse your ability to utilize everything you're capable of doing for the fact that it should exist. There are some companies who need every ounce of Kubernetes capabilities, and they're asking for more. Now, whether you use them all or not is very different from it being complex. And so I think Linux is complex. You ever look at Linux userland? We got init scripts, we got time, we got libc, we got 200-something system calls. Most people only use 8. But you stop complaining because some people need a different combination of those system calls for their app to work. So I think it's one of these things where Kubernetes is new, and we had to give ourselves times to learn. That's the reason why I wrote Kubernetes the hard way, because I thought the response to Kubernetes is complex wasn't a better shell script. If you were around in the early days of Kubernetes, remember there was a script called kubeup.sh. It was like 2 trillion lines of the best bash you've ever seen. It had modules, it was wild. And I was like, a better shell script ain't gonna help people understand what this thing is. And for us, we happen to be the doctors in this analogy. So while you, as an everyday person, doesn't understand how your body works, you expect a doctor to understand how the body works. Hey, something hurts. Oh, I have this machine. It lets me see inside. I will tell you what's wrong. and you can work on me. And we need different levels of expertise. There's brain surgeons, there's heart surgeons, there's people with different skills. That's what Kubernetes is. It requires all of those skills, and we just put them behind a common API. And so I wrote Kubernetes the hard way for the doctors and the surgeons to understand what this thing does. And then if we were doing it right, the people on the other side of this analogy just get to wake up and only call us when something is wrong.
Thanks, Kelsey. You know, I could listen to you and chat with you all day, but I think we do want to give away some books. So maybe we can have questions be asked while we set up for the book signing.
Who wants more questions? All right, book signing it is.